So tonight we're going to delve more into parabolas, and today in class we talked about the focus and the directrix. So by definition, if I asked you what a parabola was a few days ago, you would probably say it's a function that opens up or down. But after today's class, you would probably say, well, Mr. Deschler, a parabola can also be defined as the sets of points x and y in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. Well, basically what that means, you're correct if you did say that, what that means is just the distance from the focus in a point. So if you went from here to here, and then if you went from here to here. So those two lines should be equidistant. They should be the same distance. So if you hear me say distance, well, that's why in this problem they're having you use the distance formula. So let's go ahead and recall what the distance formula is. So if you said the distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, then you are correct. This is something that we've done in geometry, and you've probably done it previously. So we're going to use that formula to find the distance of PD and PF. So what I want to do is I want to set PD and I want to make it equal to PF because those are the two segments we were talking about. But before we get into that, let's go ahead and just label out points above it. Let's go ahead and put point P up here. We know that it is XY, and we know that D is X negative 2, and we know that P is still X1 on this side, and then the F we know, or the focus is 0, 2. So basically all I'm going to do is use our distance formula for P and D. We're going to find the distance from P to D and find the distance from P to F. Well, what I did is previously we wrote the points up here, but now I want to label them. Now it's up to you which way you want to label them. It doesn't really matter, but I'm going to call this my second point, and I'm going to call this my first point. So I'm going to work this side first, and then I'll go over here and work this side. So what I want to do is I want to go ahead and take x sub 2 and plug it right in, and then x sub 1, plug it in, y sub 2, plug it in, y sub 1, and plug it in. So as you see, when I plug it in, I get x minus x squared plus y minus negative 2. Simplify that out, the x's will cancel out, and you're left with the square root of y plus 2 squared. Now let's go ahead and work these. And then you should have on this side, when you do it, you plug it all in, you do your work out, you have x minus 0, so that'd be x squared, and then you have y minus 2 squared. Now what you want to do is anytime that you have a y plus 2 squared or y minus 2 squared, before we even get to that step, I want to get rid of these square roots. So what I'm going to do is I'm going to square both sides. So I'm going to square this side and square this side. And when you do that, you'll notice you have y plus 2 squared and then x squared plus y minus 2 squared. So we got rid of those for us, and that's what we wanted. So from there, what I want to do now is I want to expand this and then expand this. So when you expand y plus 2 squared, remember you want to use the box method. I'm not going to do it here, but you can look back or you can ask me in class how you do that, but you should know how to do that from previous classes. So y squared plus 4y plus 4. So that's y plus 2 expanded. And then the same thing over here, x squared. If I did the box for my y minus 2 squared, you'd get y squared minus 4y plus 4. So from there, what we want to do is we want to combine our like terms. So to combine my like terms, I'm going to subtract y squared from both sides. I'm going to go ahead and add 4y to this side, and then I'm going to subtract 4 to over here. And when you do this out, you should get 8y equals x squared. Now all we have to do is get that y by itself, so we want to go ahead and divide both sides by 8. Divide both sides by 8, and you'll get y equals 1/8 x squared. So there you have it. We have our function. We have the function that we want. So if you take that function, go ahead and plug it back into Desmos or in your graphing calculator, and you'll see you'll get the exact same graph that we had previously. So if you have any questions, please let me know. Make sure you come up with a HOT question, come up with a example, or come up with a confusion question. And what I want you to do after you do that, I'm going to give you an example, and I would like you to try that example, and I'll put it up right now. So go ahead and give this one a try. You want to use, remember that we know by definition, you guys told me earlier what the definition of a parabola was. We know that this segment right here is the same to this segment. So you want to use your distance formula. So go ahead and pause it now and see if you can figure out what the answer is. So if you did all the work, I'm just going to give you the answer here. We can go over in class, but you should get y equals -1/12 x squared. So please come in tomorrow with the work. Make sure you have your questions, and I will see you next class, and good luck.